All right, people. So we have Oleg with us, and he'll be speaking about how we got 10x performance in our socket. So without taking a lot of time, Oleg, I'll give it back to you, so you can just take over. All right.
Yeah, sure. Hello, everyone, and welcome to this presentation about how we got 10x better performance in our socket. So, just before we're gonna start at all, because it's important to clarify for whom this talk, I want to say that this talk is for beginners. And if you are pretty deep in terms of performance and you understand how to measure it, what characteristic to look at, um, and you kind of proficient in this topic, most likely this won't be really interesting to you because I won't be getting into really deep details about different reactive characteristics, reactor characteristics, and how it implies impacts on your application performance. And first of all, I have already given a talk about these things. So if you are interested about reactor performance, I recommend you to probably switch on the different thread and listen to another topic to spend your time efficiently and productively. And if you're curious about reactive performance, I gave another talk in the past, which you may find by the following link. However, if you are pretty new in the performance topic and you're curious how we did it in RSocket, and if you're curious how you can do it for your library or your application, then welcome. My name is Oleh Dokuka. I'm software engineer. I'm a big fan of reactive programming and general reactive streams and reactive system concept. I'm a part of Reactive Foundation. I'm helping to build reactive community. I'm Java champion. Um, and I'm contributor to Project Reactor. As of today, I'm leading RSocket project and basically doing my best to improve RSocket Java and other RSocket libraries and ecosystem. So if you're curious and if you want to learn more about what I'm doing, I'm encourage you to follow me at Twitter and ask if you have something in mind later at like a direct message or a tweet. So, um, first of all, we are talking about performance, but why should you care about performance at all? This is really important question to understand. Um, First of all, you may think that if performance, maybe it's because of speed, because we want to get better speed, we want to speed up all the processes that we have in our system on or in our application. Well, if you think about performance like this, then you're a little bit wrong because everything is driven by your business, and most likely your business care less about the speed of your application or the speed of your single response or your part of your component if in general the system works fine and your users are happy. On the other hand, business cares about money, so performance can be related to saving money, and of course improvement in performance can lead to a lot of savings. So that's something which your business might be interested in, and you're right, that's the right point to talk with business about if you want to improve your performance. So, performance in general, performance can be characterized by a few kind of main pillars or main topics. And of course, performance can be characterized by, in general, efficiency of your system, the scale or the scalability of your system, or basically you can treat it as a number of active users or the number of requests that you want to handle at a single point in time. And that's basically called scalability or scale. And finally, the performance and your system can be characterized by the cost that you spend on keeping your system up and running. So today it's really important because in the past we ran our application on a single machines and we didn't care about scale at all. And of course we didn't care that much about efficiency. But today the more we want, the more application, the bigger system we want to create, the more users we want to handle, the higher cost we have to pay, because everything costs something, and every machine that we ask from Amazon costs something. On the other hand, it's clear that scale depends on the cost. On the other hand, efficiency also impact all these characteristics. For example, if you have not that high efficiency of your application, but you still want to handle the same number of users, well, you have to pay a little bit more, or not a little bit, because in that case, you have to run more machines, you have to pay, you have to create more infrastructure, and of course, you have to pay for that. On the other hand, there is absolutely different part of this rule. If you don't have to run many and to handle many users, most probably you don't have to pay much, because not that efficient application at the low scale, at the low number of users, won't affect your budget much. That's kind of the truth. So the answer on should you care at all is pretty simple. You have to think what kind of scale, what kind of, how big is your business and how many users you have to serve. And if your business is not that big, if it doesn't bring that much money, if it's at low scale, most probably you don't have to care about performance. On the other hand, if you have high scale, if you are in the area of bloody enterprise, let's call it, then most probably you have to care about the every percent of your throughput and latency, because the higher overhead you have, the more you pay. So it's clear, you have to care. So how RSocket related to that context, and why I'm connecting RSocket to this absolutely unrelated topic of performance? And basically, how did we improve, and why did we care about RSocket performance? So in order to understand that, I would like to start from application scale, from not application scale, but from the business perspective, from what we build for our business. Basically, we build applications. And you may think, okay, if we build application, then our application has business logic, and maybe that's something that we have to improve if we're talking about performance. Well, on the one hand, that's true. On the other hand, business logic is just a small part of your application. And a part of your business logic, there is much more bigger part of it, which is infrastructure. And if you try just to improve your business logic, you may get success, or most probably you won't get, because you have many other dependencies on infrastructure, and depends on how you use your infrastructure, you will end up with different numbers. So again, it sounds okay, but how are RSocket related to all of that? It's clear that there is infrastructure, there is part of business logic, and we can improve business logic, but infrastructure can impact our performance a lot. Basically, in order to understand why RSocket is important in that context, let me talk a little bit what RSocket is. And let me explain a little bit about infrastructure that we have at modern applications today. First of all, we all use frameworks. It can be Spring framework, it can be Quarkus, it can be any modern framework that we want to use in order to simplify writing our server-side applications, for example. On the other hand, today we are running microservices. So basically everything is in the distributed environment. And in order to simplify all this orchestration and management of our microservices and instances, we use containers, and we containerize and isolate everything that we run, which makes sense, of course. Then we have OS, then we have hardware, and of course we have network, because our microservices has to communicate somehow with each other. So that's clear that we have something. And RSocket sits at two of those levels. First of all, RSocket is a framework. So it brings some business logic from the code perspective. On the other hand, RSocket is a network protocol. So it offers some cool features for microservices. So if you have never heard about RSocket, let me quickly introduce to you what RSocket is. Basically, RSocket is open source layer 5, layer 6 network protocol built by leaders of building microservices, distributing system, and doing real cloud native computations. So basically, those folks, when they build RSocket, they knew why they need RSocket and how they can get benefits from it, and they knew what they do because they built something really cool, really reliable. And one of the main characteristics of RSocket is basically resilience as a first citizen and first class citizen. And basically RSocket implements this reactive streams concept and brings back pressure and application flow control as the main feature. On the other hand, RSocket focus on messaging and basically let you build any messaging system and any communication type that you want. So you can build your event-driven application, or you can do RPC communication and focus only on messages. And finally, RSocket is, of course, about performance. This is one of the most important characteristics, and RSocket is way faster than your HTTP1 communication, and it uses much less resources than just normal HTTP server, which is cool. And all this sounds like shut up and take my money. We want to use RSocket, but this is just a single part. On the one hand, RSocket sounds like a part of your infrastructure, but on the other hand, from our perspective, from the developer's perspective, RSocket is somewhat similar to the normal applications, because RSocket is a framework as well. And in any framework, we have business logic. And of course, this business logic is just a small piece. But a part of the business logic, we have some infrastructure. However, if it sounds like something similar to application, RSocket is somewhat a little bit better, and it brings a little bit cooler capabilities. So from the infrastructure perspective, RSocket is kind of built on top of lower network level protocols like TCP, WebSocket, Aaron, which sounds like something we rely on, we depend on, and we cannot improve performance of that. And of course, that's true. We have kind of fixed performance. However, on the other hand, RSocket brings flexibility in terms of your transport, and you can easily switch and choose the transport and the performance of particular transport that you want. So RSocket is built higher than layer 4, which means that it's flexible in terms of underlying transport, and this is kind of one of the core concepts built inside RSocket. On the other hand, RSocket uses reactive streams, brings and gives you reactive stream semantics, which means that you have to use reactive streams libraries in order to consume RSocket API in one of the implementations. And basically, reactive stream libraries use it for end user API, that's clear. And as we figured out, basically this part is something that we can improve. So what did we do in order to improve our performance? That's really interesting question. And I really want to start from that point, because maybe you won't be interested in how you can do that, but you may be interested in what we do in order to improve our performance. So we started with RSocket Java, because our main goal when we started our development was to bring more and more libraries to stable phase. And in RSocket Java 1.0, our main focus was to bring more and more features. So for user API library, since we need to bring reactive stream semantic, we decided to go with really popular and famous project called Project Reactor. And I hope that you heard about Project Reactor in the past. So on the user API, we built everything around Project Reactor. We exposed our communication kind of calls like fire and forget, request response, and others through mono and fluxes. And that was really convenient way, because basically Project Reactor is non-blocking IO library that allows you to do all your transformation and data processing in non-blocking way. It brings you really fluent API, and of course it gives you a set of universal operators that you can embrace and use at any place of your application. And of course, a part of great fluent API cool performance that Reactor has as a first-class concept. Reactor brings really great tooling and allows you to easily debug what's going on inside your flow. That's set of the benefits that kind of was the deal maker for us, and for RSocket library and Project Reactor as a user API for this library. On the other hand, since we decided to build at least something, we decided to use Project Reactor inside RSocket and inside RSocket core implementation, and we decided to use this set of universal operators as in our logic, because it's kind of it makes sense, because it simplifies the whole development. And since we expose reactive streams, probably we have to use that inside our library as well. Well, it's reasonable. And we did that at the very beginning, and what we had looked like this. So we used all type of processors inside our implementation, because processors allowed us and enabled us to easily send frames when we received it from the network, and kind of create our publishers without writing something complex at the very beginning. And we used, apologize, some technical issues with my network. For some reason, it disappeared. So yeah, let me quickly come back and repeat from the moment that I disappeared from the screen, just in case you missed something. So we used Reactor inside RSocket really intensively, and we used all the tooling that was offered by Project Reactor, and that was fine for us just for the beginning. But Project Reactor is really cool tool, and it brings great power. But as you remember from the great story, great power is a great responsibility. And as we figured out, Project Reactor is really suitable for server-side communication, for I/O, and for building basically server-side applications, enterprise applications, which has to be efficient. But Project Reactor may not be that efficient when it comes to something low level, to some library internals. That's why having that in mind, that Project Reactor is cool, and in general the performance was fine. And once we release the 1.0 and fix most of the bugs, we start thinking about some fun parts. And in RSocket Java 1.1, we decided to improve something. And one of the key points for improvements was performance. And we decided to do that not just because RSocket was slow. No, RSocket was pretty blazing fast. We decided to do it because we could. We could improve RSocket performance, because basically RSocket is on the same level as Project Reactor. Basically, RSocket is reactive streams as a network protocol. It just exposes reactive streams API. It just exposes publishers, and you should be able to subscribe to a particular call, but nothing else. RSocket is not mandated to use something like reactive programming inside itself. So having that in mind, and being the great experts in Project Reactor, and being the contributors to Project Reactor, we decided to go breaking bets and improve the performance to the best. So for that purpose, we decided to fully customize everything related to Project Reactor and write down own operators. That's basically what we did. And that was really, really long story. We started basically, as far as I remember, at May, and we merged the PR somewhere at the end of July. And as you may notice, the number of changes was huge, which means that was not the simplest task, but we did that. And as you may see, we rewrote every operator, and we created our own interactions and our own implementations of mono and publisher. And basically, I will share at the end some links to for those who curious how did we do how did we do that, and how you can write your own implementation of publisher or subscriber just in case you want, and you have a specific case. Well, I have a talk about that, and I will share it at the end. But just by rewriting all these parts, just by removing all these operators like do on subscribe, do on error, etc., do on discard, with a custom implementation which does everything in a single place, does it at once without extra overhead, without extra object allocations, we got not just 10x better performance, but for some communication patterns, we got like 30x performance, which is great, which is just an awesome improvement. And that was success. Sounds great, but at this point you may wonder, okay, how did you know that you have to improve exactly that part? Because the library is huge. We have various of classes. We have different dependencies. We depend on reactor neti. We depend on, for example, of course, project reactor, and of course, project reactor can slow down something at some points. It's a theory. We have to figure that out, of course. So in order to understand how in order to find the bottlenecks in your application, in order to find where you can improve your app, of course, you have to look at some characteristics, and of course, you have to measure. So first steps in like you have to analyze, of course. That's clear that you have to analyze your performance. And looking at what we've done, you may think, okay, our first steps in performance analysis might look like this. We've seen the method foo, or we've seen the method RSocket request response in our socket library, and we decided that this method is not implemented optimally. Well, or looking at your application, you may think that, well, maybe database is a bottleneck, so we have to use, instead of our Postgres, we have to use Mongo, for example. Well, if you think like this, you're wrong, because basically this is the wrong steps in performance analysis, because this is just guessing. And you may debate with others, and there is no point of truth. There is no real metrics that you can look at and say that, well, this is something that we slow at. So in order to analyze performance, you have to first of all, you have to select metrics. You have to think, what do you want to measure? Do you really need, for example, requests per second? Or maybe for your application, it's really important the execution time or latency. So you have to understand what type of metrics you have to measure. For RSocket, we had in mind both, because RSocket is a network library. It's a framework which allows you to do messaging over TCP or Aaron or UDP. So for us, it's really important to understand both. The general RPS, like requests per second, that you can send over the network, and of course the latency. But in our case, this number kind of interconnected, and we can easily kind of derive one from another and vice versa, because basically RSocket is running on a single machine, so it uses and utilizes only a single connection, so everything will be limited to our library performance, which is kind of a small proxy, and of course to the network performance. On the other hand, you have to ensure that your metrics that you are measuring, and for example, the method that you are looking at is a proper one. So you have to think whether a particular metrics or a particular method that you are measuring is a correct one. For example, in our case, once we started working on performance, RSocket Java performance, we first thought about hot methods and what kind of and what type of methods will be executed most frequently. For us, it was kind of obvious. Most of the users will be using fire and forget, which is kind of just a single request and basically no response at all. So I have just to flash my message to the network, and that's it. On the other hand, one of the most frequent operation is kind of request reply or request response. So we expect that this method will be used most frequently. So our focus was dedicated to those kind of uni operators or unicall operators, which were dedicated to sending a single payload and receiving a single response. Talking about Flux, Flux was less relevant for our case, so we rewrote and created the custom operators. So in reality, the performance difference wasn't that huge, but we still did that because we could. But you have to think, if your operation that you trying to optimize is relevant for you, because you may get like 10x better performance, but for reality it can just save just a few milliseconds of your time. So this is important part as well. And finally, once you're planning and once you're doing analysis, you have to set the end goal. And of course, this end goal has to be a speed of performance, because measuring something, analyzing metrics is basically use case if you don't have the final goal to improve performance. So a part of that, you have to think when you try to improve performance, and what we thought about when we try to improve performance at RSocket is what can be optimized. And as I said, we optimize one part related to Project Reactor, but it may be not always relevant for every one of us. So I just want to share what you can optimize in your application. So in general, there is two types of optimization. There is macro optimizations. It's basically the high level optimizations. And here can be your database access, or it can be the number of I operations. And basically, this is the core part that you may start looking at if you want to optimize the performance of your business operation. Because, for example, if you're doing too many database access, or if you do too many IO interactions, and in theory you can decrease the number of these operations just by setting a cache somewhere in between your requester and the data source, well, you will be able to get a great improvement in performance. And that's true. And maybe you don't have to care about all other stuff that we cared about in our case. On the other hand, if you're trying to build something low level, if you want to get microseconds, milliseconds of your performance, most likely you want to take a look at micro optimizations, which is another part of optimizations. And this type of optimizations includes some code parts, which can be algorithms, how you structure your code, class hierarchy, etc., etc. It can be basically anything which might not be or may not be optimized by your language platform. And of course, we know that in JVM we have pretty cool just-in-time compiler which help us to optimize our performance and keep our code clean. But on the other hand, just-in-time compiler cannot always do that. So probably we want to optimize and look at some allocations that we do in our code and so forth and so on. So this is part that we may optimize, and it of course depends on what you want to achieve in your app. So the final questions that you may wonder about is, of course, how to measure everything that you optimize, because what I said is just a theory. And what I've shown is just the results, but how you may measure that, this is important part. First of all, you may ask your users. If you are already in production and you're running something that is working and bringing money, then of course you can go to your users and ask. And this method of performance measurement is of course efficient, because it represents the reality. You may get the qualitative feedback from users. They may say, well, your service works fast. You don't have to care about performance. On the other hand, if you're running something in production, you collect all this type of metrics, so you don't have to even do some extra actions. You already have all the metrics reported to some metric system. So you can look at them and see how your system behaves. However, it's not always possible, especially when you are at the very beginning and when you don't have too many users that can report. So this method is cool when you're big enterprise and big application, which is up and running, but it's not useful for those who just starting and need to understand the performance. On the other hand, there is another type of testing that I want to emphasize. Is basically end-to-end load testing, which can help you to measure the capacity of your system, because you can run multiple machines. You can connect to the whole to your whole system, which can be pretty close to the real production environment, which can run multiple instances and so forth and so on. And you can see your throughput and latency at scale. Of course, using end-to-end load testing, you can try different cases. You can try to, for example, if you're using stateful connections like HTTP2, or for example, if you're using RSocket over TCP or WebSocket, of course you can try different cases and see if too frequent connection handling decrease the performance, or how system behaves if you have this number of connected users which are sending requests continuously, and so forth and so on. However, this type of testing may be useless if you want to understand the details of every component that you have in your system, because it's not always possible. Of course, it's possible, and you can connect to every part of your system, to every microservices, different agents that are going to be collecting information about your platform and your, for example, Java application. But of course, it's not always possible. It's possible, but it's harder than, for example, in another type of testing, which is micro benchmarks. So probably most of you heard about micro benchmarks, and in Java, most of you probably used Java micro benchmarks. And micro benchmarks is useful because they can measure code, and they can show you how your code behaves and how your code impacts your particular small this unit of your application or small component behavior. Because measuring the part of your code, you can see the number of allocations, the number of GC policies, etc., which may be useful. Not that useful for the whole system understanding, but it's useful for understanding of the performance of your small part of the system. So it was basically useful for us because we are a small library, a small framework, which brings some tiny functionality which you can use in your big application. So for us, using micro benchmarks was the really right choice. So we used micro benchmarks, as I said, and with micro benchmarks, we were able to collect flame graphs. And basically, while we were collecting the flame graphs, we figured out that we don't spend much CPU, because flame graphs basically shown how much time we spend at particular invocation, and basically it shows the stacks, stack lengths, etc. But in general, we can see how much time we spend at particular call, which can show that, for example, something is slow or something is not that slow compares to the other executions. On the other hand, so what we've seen collecting flame graphs, we've seen that we don't spend much time in our business logic, which was good for us. Of course, we spent a little bit more time on the lower levels like Netty or Reactor Netty, but that's something that we were not able to improve. So we started looking at GC pauses, and what we figured out collecting GC pauses during our socket measurements is that we have too many, relatively too many GC pauses. And as we figured out, we have too many object allocations. And as a result, we figured out that project reactor allocates some number of objects, depends on how many intermediate or universal operators you put in the middle. So having all these things in mind, we tried the same with the new operators, and we figured out that the GC pauses, the number of GC pauses decreased, and the number of allocated objects was decreased as well, which was kind of a win for us, an explanation on how we improve the performance. So basically, that's all the story. We started from understanding why performance improvement is somewhat important. We understood that it's important, not always. It depends on your scale, and maybe it depends on the current efficiency of your application and how much your business spent, how much money your business spent on your infrastructure. We went through the understanding of RSocket and what we did at RSocket in order to improve the performance. And finally, we quickly covered how you can improve and what you should look at while improving your performance. So with that, again, if you're interested in understanding where the reactive streams overhead come from, what you can get using Project Reactor, how you should use Project Reactor in order to get better numbers, I'm encourage you to look at my previous talks about reactive performance. And basically here I'm covering during 2 hours how you can tune your GC, what GC you can use, etc., which is detailed and in-depth, interesting talk. On the other, a part of that, you have to remember that performance is important, but yeah, of course, if your business brings money. If you have 0 income, maybe you have to spend 0 money on your performance improvement. Performance is like a fitness. You have to do something only if you know that you have something extra, or if you an average weighted, probably you don't have to spend much time on performance, and only what you have to care is how to keep your weight at the same level without eating too much things from the frameworks and using too much frameworks in your infrastructure. And finally, you have to remember that you have to measure your performance properly. You have to look at the proper executions. You have to understand your system architecture, your system design, and how your system behaves for every particular call and execution. With that, basically, thank you for your attention. And if you have any question, don't hesitate to ask me.